Other type of non-pilot-aided scheme we will discuss is the Zone 1 extension scheme. The Zone 1 extension scheme is an enhancement to the stepped distance scheme covered in the previous section. This protection scheme operates on the principle that most transmission line faults are transient in nature, which means the fault is not permanent. For example, the most common cause of faults on transmission lines is lightning. If lightning strikes a transmission line, it ionizes the air, which reduces the resistance between the different phases of the line. This reduced resistance allows for a path for current to flow, and hence creates a fault. Once the transmission line is tripped and the fault is cleared, the ionized air is removed and there no longer exists a path for current to flow. Closing the transmission line circuit breaker at this point would re-energize the line and transmission of power could resume. As mentioned before, the Zone 1 extension scheme is like the stepped distance scheme where it has 4 zones of protection. The difference between the two schemes is that in the Zone 1 extension scheme, an additional Zone 1 impedance setting is set higher to overreach into the next adjacent transmission line. The impedance of this extended Zone 1, which is labeled Z1X, is usually set to the same impedance as the Zone 2 setting of 120% of the impedance of the entire transmission line. This extended Zone 1 is used by the distance relay until it detects a fault within this zone of protection. Once a fault is detected, the relay will immediately trip the transmission line since there is no delay in the operation in the extended Zone 1 element. As you can see, the relay will trip the line even though the fault may exist in the area located in the extended Zone 1 but be in the adjacent transmission line. Once the breaker is opened and the fault is cleared, the relay will then automatically reclose the breaker and re-energize the transmission line. Once the line has been reclosed, the relay will then use the standard Zone 1 characteristic and now underreach to only protect an area within its own transmission line. If the fault that occurred was a permanent fault and the fault is located within the transmission line's newly shortened Zone 1, the relay will trip and again open the circuit breaker to clear the fault. If the fault was transient in nature, the first occurrence of tripping the line would have removed the fault and transmission of power would resume. If the fault that occurred was a permanent fault and reappeared after the reclosing, but was not located in the new shortened Zone 1 protected area, the relay would not pick this up for a second time in Zone 1 and not trip to try to clear the fault. The permanent fault would then be cleared by the Zone 2 protection after the set time delay if the fault fell inside the transmission line's end zone area. If the permanent fault was picked up by the relay Zone 2 because it was located at the beginning of the next adjoining transmission line, the relay protecting that transmission line would pick it up in its Zone 1 of protection and clear the fault. The disadvantage of the Zone 1 extension scheme is that external faults within the extended Zone 1 reach of the relay trip the breaker instantaneously, even if that breaker did not need to be tripped. This needless tripping increases the amount of breaker maintenance needed and causes a needless loss of power supply to some customers.